This is section 4.1, and in this chapter, we're going to look at different types of number systems. And I think that you'll find that this will be very interesting. In section 4.1, we're actually going to look at the Egyptian, the Babylonian, and the Roman numeration systems. And these systems actually help us to understand our own decimal system, and they'll help us to see how we actually incorporate some of the ideas of these earlier systems into our very own system. The first system that we're going to look at is the Egyptian numeration system. The Egyptian numeration system is probably one of the earliest types of written numeration systems. It's pretty simple, and they use kind of a grouping system. And so let's take a look at how they use this system. You're going to see this chart, and I have this chart actually printed for you in the notes, and this is a chart that you're going to want to keep handy. And so the Egyptians used these types of hieroglyphics, and you'll see this in lots of different drawings. And so you'll want to make sure that you keep this particular chart handy. It will help you as you work through some of these problems. So the way that the Egyptians used these symbols is that basically they used the addition principle, which they basically just added these symbols next to each other, and that's how they did that. And so let's take a look at a few examples. So here's an example where we have this type of hieroglyphics, and they want us to actually translate this into our decimal number. And so let's take a look, and what we're going to do to find the solution is we're going to take each of these groupings of numbers, and then we're going to translate them using that chart that I gave you a couple of slides back. So what I've done is I like to write these vertically. So I took each grouping. So this finger here represents 10,000, and you have one of them, so it's going to be 10,000. Then you have the next one is the lotus flower, and you have two of them, and so that's 2,000. Then you have three of these, and so those represent 100, so that's 300. And then you have 10 times 4, so that's 40. And then these marks, there are 5 of those. And so then all you have to do is add all of these up. So when you add all of these up, that gets to the number 12,345. So this hieroglyphics right here, that represents our numeral number 12,345. Now, what's interesting is that in the Egyptians, the position of the actual symbols is not important. So if you notice right here, you could rearrange these symbols, and they kept the groupings together, but you could rearrange them and you get the same number. And so it doesn't matter that they didn't have to put them in order or anything like that from least to greatest. So just know that don't let that trip you up if you saw that in an example or something with your homework. The other neat thing that the Egyptians did is that they used an oval over their existing number system to display a fraction. So for example, they had 3 hashes here, and then you put this oval over it, and it represented 1/3. This represents 1/4, 1/10, and then this was 1/33. They did have a couple of exceptions. So 1/2 and 2/3 were exceptions. So 1/2 you could rewrite as 1/2, 1 over these 2 hash marks, but they also had this little whatever you want to call that right there. It represents 1/2, and then this also represents 2/3, and so does this. This represents 2/3. So they had a couple of different unique representations for these fractions. Now, when you go to enter in WebAssign, you are going to have one example I saw of a fraction. So let's just say in WebAssign you were going to enter in, you had a question where you had to enter in the answer 1/33. In WebAssign, in that box, you would type in 1 and then your slash, it's a /33. So just make sure that / is right by your shift key, like underneath the question mark. So just make sure you use the / and not the backslash. So just kind of a way to make sure you get that problem correct on your homework. Now let's take a look at the Roman number system. So this is one that you're probably a little bit more familiar with. You're probably pretty familiar with the Roman numeral system. It was used in Europe until the 18th century, and it's still used today a lot in outlines, and you'll see it in page numbers for books and copyright dates, things like that. So you'll see this table at the bottom of the page, and I've tried to put this table at the bottom of several of these slides, but it's also on the handout that I gave you for this section. So it's one that'll help you to work through these problems. So the Roman numeral system is repetitive. It's similar to the Egyptian system, but it has a couple of additional properties, and these additional properties are the subtraction principle and the multiplication principle. So the subtraction principle, whenever you start reading, you read from the left, and you're always going to add the value of each numeral unless the value is smaller than the value of the number to the right. In that case, you subtract from that number. Now there are a couple of extra little things to that, and we'll see that on the next slide. So only the numbers 1, 10, 100, 1,000, so on. These are the only numbers that can be subtracted. And this comes into play in a couple of your examples in your homework. They can only be subtracted from the next two higher numbers. So this is something, again, I'm going to repeat that. Only the numbers 1, 10, 100, so multiples of 10. Those are the only ones. So 1 and then multiples of 10 can only be subtracted, and they can only be subtracted from the next two higher numbers. Okay, so instead of saying 4, like 4 hash marks, we're going to write 1V, and so I'm sure that you've seen that before. So in other words, XL means 50 minus 10, which is 40. Okay, so we're going to look at some of these examples, how this plays out in some examples. You also have a multiplication principle. The multiplication principle is used, and you'll see it with a bar. The bar is placed over a Roman numeral or a group of numerals, and basically that means that it is 1,000 times the value of whatever it's written over. So you'll see this bar, and that's called the multiplication principle, and you'll see that in some examples that we are going to look at. So for example, if you have the bar written over a V, that means 5 times 1,000, which is 5,000. A bar written over XL means 40 times 1,000, which would be 40,000. Now there is a little bit different here. So for example, you would not have an I with a bar over it to represent 1,000 because we already have an M. M is already used for 1,000. So if you already have a symbol for that, then you would not use the bar. So you wouldn't do that. Okay, let's take a look at several examples. The first one here, write each Roman numeral as a decimal number. Okay, CCLXIII, and I've given you the chart down at the bottom for a reference. So the way that I'm going to do that is similar to how I did it before, is that I like to write these out vertically. So I grouped the letters C, C, L, X, and then all of my I's together. So CC is going to be my hundreds. So there's two of them, so that would be 200. Then L is 50, X is 10, and then the three I's would be 3. And then you add them all together and you get 263. So that's pretty straightforward. So that one's not too bad. Let's look at another one. In this example, we've got a good bit going on. So we're going to take, and you kind of have to read this from left to right. And then you have to realize we've got some that we're going to have to use our subtraction principle. So MC, MX, CIX. All right, so the way that I'm going to write this, I grouped them in this way. So that I wrote M and then I did CM. And the reason why I did CM is because I started out with M and then I noticed that the next one was a C. So that means I went backwards. So that means I'm going to use a subtraction principle. So I grouped C and M together. The next one, and then I had XC and I went backwards again, so I grouped the next two together, and again I went backwards again, so I did IX. So that's how I know how to group these together. So now let's take a look at that. So M is 1,000, so that one's pretty straightforward. Now CM. CM is going to be 1,000 minus 100. So 1,000 minus 100 would be 900. And then XC, we're going to have 100 minus 10. So 100 minus 10, which is 90. And then we're going to have IX, which is 10 minus 1, which is 9. And then you're going to add all of those up, and that's 1,999. So that would be your final answer on that. Now let's look at an example that has the multiplication principle being used. So we have CD with a bar, CLIX. So I'm going to write this out. So I've got my CD and then CL and then the IX. So my CD, so if you notice here, I've got 500 minus 100. So I'm looking at the C and the D. So I have 500 minus the 100. So that gives me 400. And then the bar on the top means that I have to multiply it by 1,000. So 400 times 1,000 gives me 400,000. All right, so hopefully that makes sense. And then C is by itself, so that's going to be 100. L is by itself, and that's going to be 50. And then IX is going to be 10 minus 1, which is 9. So then you add all of those up, and you get 400,159. So these look really difficult to begin with, but you really want to take your time and take them apart, see how you need to group them, and then take each individual piece and put them back together. And then it's not quite as intimidating. All right, now we're going to look at we're going to go backwards. We're going to start with our decimal number and we're going to try to turn it into a Roman numeral. So the first one is 49. Now, when I first looked at this, I just thought, well, that should be pretty easy because you ought to be able just to use the subtraction principle and just say, well, there's 50 and minus 1. But the problem is that you can only use the subtraction principle with 2 levels. You can only go 2 levels. So in other words, you can only, so like 1 can only be subtracted from 10. So 10 can be subtracted from 50, but that's all that can be subtracted from 50. So in order to get 49, I have to start with 50, but I can only subtract 10. So that changed how I wanted to work this problem. So in other words, how I decided we had to do this is that I had to say 40 plus 9. All right, so now let's think about how are we going to get 40? So to get 40, I am going to have to take 50 and subtract 10. All right, so to get 50, I'm going to take 50 is my L, and then I'm going to subtract 10, so that would be XL. And then to get 9, I want you to think about that for a second, and if you need to, pause the video, and I want you to think, how are we going to get 9? All right, so hopefully you saw to get 9, we're going to take 10 and we're going to subtract 1. And so to do that, we're going to get IX. So in WebAssign, you would actually type this in as XLIX. Now we're going to look at a big example, 345,123. So this is going to take a lot of different steps and a lot of different ways to break this down. So the first thing we're going to do is we're going to break this down into 345,000 and then 123. Now, first we're just going to look at 345,000, and that is going to take several different steps to break that up. So the way we're going to do that is we're going to look at 345 times 1,000. Now, if you remember, Roman numerals has that 1,000 where you would use that bar. So what I'm going to do is I'm going to come way over here and I'm going to go ahead so that I don't forget that bar. I'm going to go ahead and put that bar. So I'm going to have the bar over here as to remind myself, I'm going to do 345, and whatever 345 is in Roman numerals, I'm going to put a bar over it, and that's going to take care of that 1,000. Okay. So now I need to do 345. So I'm going to do 340 and then 5. So 300 is not so bad. 300 is just 3 C's. Then 40, if you think about 40, we're just going to take 10 away from 50. So that's XL. And then 5 is just V. So now you put all of that together, and 345 is this long, the long number CCCXLV. So CCCXLV, so 345,000 is CCCXLV with this bar on top of it. All right, so that gives me 345,000. Now I have to come down here and look at 123. So I'm going to look at that, and I'm going to do 120 and then 3. So that one should not be too bad. I just have 100, which is C, 20, which will be 2 X's, and then 3 I's. Now I'm going to put all of that together, C, X, X, I. Now then my final answer is these 2 long things put together. So that would be your final answer that you would put. And these answers that have bars over them, whenever you go in WebAssign, more than likely this is going to be like a multiple choice answer. So that will be good. You won't have to try to figure out how to get that bar over there. So anyway, but this one was pretty complicated. Now we're going to take a look at the Babylonian number system. The Babylonians used a simple grouping system, and it was different from the Egyptians. They used more of the position of their symbols meant a whole lot more to them. And so they had simple symbols, but the position of those symbols meant a whole lot more. So you'll see what we're talking about here in a second. For the Babylonians, they really only had two different symbols. They have this triangle shape, and then they have this more like a square shape. So those are the only two symbols that they have. And so if you can look here, the triangle shape represents our decimal ones, and then the square shape represents the tens, and then it goes up to 59, and then starting with 60, things change a little bit. So when you get to 60, you get multiples of 60. So if you look at this example down here, whenever you get this grouping to the right, so all of these triangles are ones, so that's 5, and this is 3 tens, so that's 35. And then everything over here, this triangle to the left means that that is one group of 60. So this means that you have 60 plus 35. So this actually represents the number 95, which is, I know, strange, but that's how the Babylonians did it. So let's take a look at this example and see if we can't figure out what it represents in our decimal form. So we are going to group these, and I'm going to do it vertically because that's how I like to read these. So if you notice, I started out down here at the bottom, I took my 6, and then I took the 110, and then I grouped these together. So the reason why I did that is because this together represents however many 60s that are represented in this number. So this would be 23 sets of 60. So that would be 23 times 60, which is 1,380. Okay. Then this is just tens, and these are just ones. So that would be 10, 110. And then this would be 6 ones. And then you add all of those up and you get 1,396. So this would represent 1,396. So if the Babylonians weren't interesting enough in the way that they did their groupings, they actually added a second set of repeating, and if they repeated these figures again, it actually represented 60 squared. So let's take a look at how this works out. So in this particular numeration, we actually have 3 different sets. So we have this first set, then we have, which the red set is my 60 squared group. Then you have the yellow set, which represents my 60 group, and then you have just your regular numbers. So let's see how this all is going to work out. So I'm going to write them vertically. So when you have those first set of 2 triangles, okay, so we have this right here. That means you're going to have 2 sets of 60 squared. And 60 squared, again, is 60 times 60, which is 3,600. So this would be 2 sets of 60 squared. So that would be 7,200. Okay. Now, your second group, which is this yellow group, would be 45. So that means you have 60 times 45, because that's my 60s group. and that would be 2,700. And then your third group is going to be 24, and that's just your plain just 24. So then you would add all of that up together, and you would get 9,924. So that's how that number would turn out. So I guess where the Babylonians, since they only had two symbols, they made up for it by using all of these different interesting ways. They had a subtraction symbol. And so this little bar right here is subtraction symbol. And so for the example 38, you could write 38 and that could be written with 3 10s and 8 1s. Or you could write 40 and then you could have the subtraction symbol and you could subtract 2. So 38 could be written either way. Now let's look at an example of how they would involve that subtraction symbol. Okay, so now we're going to take a look at this last example, and I'm going to write it vertically again. And so when you write this vertically, we are going to have those first 3 triangles, and that's going to be my 60s group. And so my 60s group would be 60 times 3, which is 180. Then you're going to have 2 10s, so that gives you 20. And then you're going to subtract 1. So that, because this is under this bar, that means we're going to subtract 1. So then you're going to add all of this up. And when you add all of that up, you get 199. So that's an example that will show you how to use the subtraction principle with the Babylonians. All right, that's going to finish up section 4.1. I hope this helps you with these examples, and I hope you found this very interesting.